To make a game, you need to make sure that your player can actually input actions, pressing keys to make your character move and attack and jump and dodge and whatever. So let's talk about Unity's input system. There's two options that you can go with. The old legacy system, which is what's enabled by default when you make a new project. I have an entirely separate video about using that system to make a character controller, so go check that out if you want to. Today we're going to be talking about the new character input system because it's better, it's more flexible, and it's probably what you're going to be using, especially moving forward into the future. So first things first, to enable that, you'll come up here to Window and open the Package Manager. That will open up this over here, and probably by default your packages will be set to being in project. So that will show you all the packages that currently exist within your project. We want to add something that's not in our project. So instead you should switch over to Unity Registry and then scroll down until you see Input System. I already have it installed, but you just simply select it, and then where it says remove here, for me, it will say install for you. It will prompt you with a pop-up saying, hey, you already have the old system enabled. We'll have to restart the engine and disable the old system if you want this to work, which is fine because we're not going to be using the old system. Now that the engine has restarted, we can put that new input system on a player. But before we can do that, we actually need a player. In our hierarchy, let's just make a new 2D object. Let's make it a square and let's make it, I don't know, yellow, the fun color. This will be our test player for the time being. So we're going to add a component to that, and that component will be a player input component. Needs a couple of things. Everything down here we can ignore for right now. What we need is a input action asset, which we don't have, but luckily we can create actions which will just provide us, we can just save that, with the default things we need. So that's moving, looking, and firing, and then also some UI related stuff that we're not going to get into right now. You can make as many of these actions as you want, and under every action you have the inputs that corresponds to that action. So for moving, we've got let's go with WASD, which also has the keyboard arrows in it. If we go into the up key, which is W, we can see that the composite part here is set to up, and the up arrow is also set to up. S is set to down, and the down arrow is set to down, and so on and so forth. This information will be converted into a vector 2, which in the next video we're going to get deeper into different variable types and what vectors are and how to use them and how they work. But for now, just know that this vector 2 value has two numbers in it, an X number and a Y number. So if we press up or down, the number corresponding to up and down will change. If we press left and right, the number corresponding to left and right will change. If we press both at the same time, both numbers will change. Might sound a little bit abstract, so let's actually use this very thing as the example that I'll show you how it works with. So coming down here, we're gonna open up the console real quick because we're gonna be using that to show off how these inputs work. Before we make any scripts to make use of this, I want to pull your attention back towards the player input components, because we've got a couple of different behavior types that we can use. We can send messages, we can broadcast messages, we can invoke Unity events or invoke C# events. For the time being, we're going to just stick with sending messages because it's the most straightforward out of the bunch. And you can see this will send messages which just work as functions, more or less, or events, to the game object that this is on. So we've got on device lost, on device regained, which is really useful, so you can actually execute code when people unplug their controllers or something like that. But the more important ones are on move, on look, on fire. Because if you notice, move, look, and fire are the actions that exist over here. And if I make a new action myself, and I call it test, for instance, and I save this asset, you see this list updates, and now it also has on test. So if we look for any of these in a script that exists on this game object, whenever any of these inputs happen, we can execute code. I'm going to delete the on test because we're not actually going to use it. And let's make a script to show you how that works. So let's call this script player movement, because eventually that's what this is going to turn into. So we want to be able to see our input for movement, right? So what we do is we make a new function starting with void, as we've learned, and we'll call this onMove. It needs to match exactly with the message that the player input system is sending. So do be mindful of that. We also need to be using a new namespace. So we'll be using Unity Engine dot input system so that we can actually use the variable types that come with the input system. The most important one of that being the input value, which is a variable type that holds the input value. This can be a lot of different things, as we discussed before. The movement is a vector too, which means that it holds two numbers, but it could also be a bool or a trigger or something like that, right? Let's just call that value. And if you want to test something out without necessarily having to program any functional code, we can use the print function that Unity comes with, and we can just print out the value. And that's it, right? Well, not quite. Let's see what this prints out. So in our console over here, when we run the game, first and foremost, you'll see nothing happens. So when I press the arrow keys, so this will be the left arrow, it prints out Unity Engine input system input value. And when I let go of it, it still does that. And that's because it's not printing out the value inside of it. It's just printing out the reference to the variable itself. So we'll get a little bit more into this in the next video. Again, after value, we're going to place a dot, and that allows us to get access to one layer deeper into the variable, because this variable holds a lot of different functions, variables in and of itself. We're going to be looking for a function called get with the little spiky arrow things and parentheses after it, because you need to end every function with parentheses. And we're going to be getting the vector2 out of here. So now it will actually print out the two numbers that correspond to my input. So now if I press the left arrow, you can see that prints out -1, 0. -1 because I'm going left, and 0 because I'm not going up or down. If I now add pressing the up button to it, you can see it's -0.71, positive 0.71, because it automatically normalizes into always being fair with diagonal input. Especially for movement, if you would make this 1-1, that would technically mean that you travel faster diagonally than horizontally, which doesn't make a lot of sense. So it automatically compensates for that, which is really nice. What you also might notice is that it only updates when I press a new key, or as you'll be able to see, when I let go of key. So that onMove function, that code being triggered through the message and from this component over here, only fires when the actual value that it holds changes. It's not like update where it goes every single frame, because in the old system that Unity used to use, all your inputs would have to be checked every single frame. And while behind the scenes it of course still does that, you as a programmer don't have to worry about that anymore. But just printing out a couple of numbers into this console, which the player will never see, doesn't strike me as particularly useful, does it? You would be right. But now that we know that we're getting a vector2 value, even if we don't quite understand what that is in its full, we can make a new vector2 and call it something like dir for direction. And we know that we can set this, because it's a vector2 as well, so we can just set this to be equal to whatever our last input was. So if we are not inputting anything, this will be 0, 0. If we're inputting left, this will be -1, 0. For putting in the up arrow, this will be 0, +1. And then when we let go again, this will go back to being 0, 0. But in order to use this to move around, we're actually going to need to go back into the engine real quick, and we're going to need to add a new component. And that component will be the rigid body 2D. We talked a little bit about rigid bodies before, I believe. This is just a component that tells this square, hey, you have gravity and physics in general. So we can now apply forces to it, and we can influence its velocity and that kind of stuff. And it comes with a gravity scale as well, which we're going to set to 0 because I'm just going to make top-down controls, since those are by far the easiest to do. But now that we have that, we can actually make a variable for our rigid body 2D. You can always make a variable for the rigid body 2D, but we need to be able to give it a value. So let's give it the name RB. And then in our start function, we can say that the RB equals get component rigid body 2D. So that is this variable, RB is going to look for a rigid body 2D component on the game object that this script is attached to. If it finds one, now this variable is going to point towards that component, and that's exactly what we want. Then in our update function, we'll just set our RB.velocity to be equal to our direction. And now our inputs actually let us move around. It's really, really slowly, but we can move around and it's almost like a real game. From there, obviously, we can make a public float for something like speed. And we can simply multiply the direction with that speed variable. So now if we set the speed to 5 in our player movement here, you'll be able to see that we're moving around 5 times faster. That is basically the input system for Unity. There's a lot more depth to it. There's a lot more trickery and weird stuff that you can do. Again, some of the bits here might be hard to understand without understanding exactly what the vectors are and how you can dive deeper into the value of a certain variable, like with the vector 2 we just did, like with this input value we just did. We put in that dot and then we got something else out of it. And if you don't quite understand how that works, or with the rigid body, we'll get into that deeper in the next video. I want to dedicate a video to that by itself, because while it's hard to explain, it's hard to understand. It's also vitally important to understanding what you're doing when you're coding. But if you didn't have any issues with understanding the whole rigid body and vector 2 thing, that's pretty much how the input system for Unity works. And thanks to my patrons, you can see them on screen right now. And a special thank you to my Cave Digger tier Patreon, Syntax.